Good morning. So I'm going to take the topic pseudogenes. So pseudogenes, if we say it simply, it means it's the defective copy of a normal gene. In our body, we know there are lots of genes in which it's a defective copy. That means the exact copy of the original gene, but it will be non-functional. So that is simply known as pseudogenes. That is a defective copy of normal gene. And the word pseudogene was first used by Jack et al. At 1977. So, as it was said, the pseudogenes are the mutant, imperfect, and non functional genes which are homologous to the functional at different loci. It was said before, same way that it will be the homologous, that means the same copy of our original gene, but it will be non-functional, imperfect, and mutant. So that is pseudogenes. In fact, it will be the divergent member of gene families. That is, it became non-functional through mutation or by the course of evolution. So they have a sequence which corresponds to exons and introns of functional genes. That means, as in genes there are introns and exons, same as in our pseudogenes there will be introns and exons, but still as if they are having introns and exons, but like a normal gene it will not be functional, so there will not happen any translational or transcriptional powers or something like that. It's because only due to the mutational change. So the pseudogenes, we can say, how can we define it? We can say it has the defective and non-functional copies of functional gene without power of expression. And the functional gene which are homologous to the pseudogenes, that means which is same as the pseudogenes, means the functional genes are original genes, which is same as the pseudogenes, they are called as the productive genes. And the pseudogenes producing mutations are mostly nonsense mutations which generate stop codon and result in premature transcription of translation. That means the premature, at the time of premature type, the pseudogenes, which is we said it produces mutations, so that generates a stop codon when before the termination, premature of the termination. Some pseudogenes differ from the parent gene in having lost their introns. And as we said before, that like in our normal gene we have introns and exons, same way it will be homologous in the pseudogenes. But in some genes there will be a different. It's because of the loss of introns or in the absence of introns. So the pseudogenes are regarded as debris or evolutionary relics accumulated in the genome as the dead end of evolutionary process. Now, the pseudogenes can be more commonly seen in eukaryotic gene families, and few examples for is that too in humans is the example for the gene families are human actin gene, alpha and beta globin gene, immunoglobin genes, and etc. These are all the examples in which we can see the pseudogenes. Like we said, we can just see some examples for that. That is, if it's an actin gene family, it contains 20 copies of same genes of pseudogenes. Actin gene family contains 20 copies of pseudogenes, and alpha globin gene contains 4 functional genes and 3 pseudogenes, and beta globin gene family contains 5 functional genes and 1 or 2 pseudogenes. Now we are going to say about the pseudogenes, how much types it is. There are 3 types of pseudogenes, as we say, that are processed pseudogenes, unprocessed pseudogenes, and unitary or disabled pseudogenes. So let us see what all are that. So first one is processed pseudogenes. What is the specialty, or what we can say about it is it lacks the promoter. So dead on arrival contain polyatrial. It lack intron sequence, random association with parent gene. So it will lack promoter, it lacks the intron sequence, and it is randomly associated with its parent gene. And unprocessed pseudogene, they have the highest structural similarity. That means the unprocessed genes will be highly similar to the parent gene, and have intact exons and introns. So exons and introns will be present in them, and they are prevalence of ORF disrupting mutations and have close association with their parents. So as we seen first one processed, in that we said that introns are lacking and random association with parent gene, but in unprocessed gene there is exons and introns presence, and they are very similar to the parent gene and they are very close to the parent gene. Now last one is unitary pseudogenes, where no gene duplication before pseudogenization. They are rare in occurrence and have fixed disable mutations. So we have said what is pseudogene, how it was, and then we said there are three types, that is process, unprocessed and unitary. Now we are going to say that pseudogenes are generally of two classes, that is orphans and retropseudogenes. So orphans and retropseudogenes. So firstly we can say about the orphans, which is also called as non-processed pseudogenes, and let's see what all are the features or something. So they are the dispersed solitary pseudogene which show almost all structural features of functional genes. So orphans are those genes which show the exact structural features of functional genes. That is, our original genes or our normal genes extract structural function or structural features is shown by the orphan genes, such as the presence of promoter, introns, exons, and etc. They may be found by addition or deletion mutation during gene duplication in multigene families. In multigene families, what we can see is that the genes are duplicated. It can be by the duplication can be occurred by the addition or deletion. And these orphans are more close to their parent gene or more closely located to their parent gene. The example for the orphan gene is globin gene families. Next is retropseudogenes. So retropseudogenes can also be said as processed pseudogenes. We said orphans are said as non-processed and retropseudogenes are said as processed pseudogenes. They are the defective DNA copies of mRNA. So they will be mRNA's defective DNA copies. So as we said in orphans, that there are promoters, introns, exons, but in retropseudogenes there will not be. There will be the absence of introns, but they have polyadenylate tail at the 3' end and short flanking direct repeats. And here the promoter and other sequence necessary for transcription are also absent. It's before in orphans we said they all are present, but here in retro they all will be absent, and so as they will be absent, that is the promoters and the introns and all which is necessary for a transcription process, so there will not happen any translational or there will not happen transcriptional and translational powers. So in the absence of introns, retropseudogenes resembles the mature mRNA transcript of the parent gene. So here what happens, as we said introns are absent, so it normally resembles has the mature mRNA's transcript. The mature mRNA transcripts same resembles will be shown here in retropseudogenes. Hence they are called processed pseudogenes. And these retropseudogenes are not located close to the parent gene. In orphans, we said they will be located close to their parent gene, but in retropseudogenes, they will be not located near the parent gene, but are separated from them by long physical distance in the DNA. So this resembles transposable elements. It is believed that they might have probably originated by the defective reverse transcription of a processed mRNA intermediate. So as it is said or it is believed that this defective copies or this pseudogenes or this retropseudogenes is formed while the retranscriptional process occurred in mRNA. The process by which a pseudogenes become possessively shorter through the accumulation of deletion is called pseudogene length abbreviation. So what do you mean by pseudogene length abbreviation is, has the pseudogenes become progressively shorter due to the deletion process, It said has pseudogene length aberration. As a result, the pseudogene will lose, it will lose its similarity to the functional gene, as it is, as we said before that it's really similar to the functional genes, but here due to the aberration, so the pseudogenes will lose its similarity which was with their functional genes and melt into the background of its surrounding DNA. And the accumulation of deletion in pseudogenes for length aberration, if it's for length aberration, then it's said to be pseudogene compositional assimilation. Next, we are going to learn about the role of pseudogenes. So it was said that actually the role of pseudogenes, exact role of the pseudogene is not available or not understood, but it is believed that they have some role in regulating the activity of neighboring genes. They have an ability to evolve the functional gene, the new roles that are different from those of the, they will be having an ability which is involved from the functional gene, and the orphans are to be considered as a reservoir of sequence which are involved in new functions. And it said that the pseudogenes are rarely important, or it's mostly important in the evolution of higher organism. It is said by. So these are the references which had been referred. So thank you. And as we said once again, if I would say, then I would say that simply the pseudogenes are meant that it's a defective copy of our normal gene, and it is a defective copy, it's a non-functional copy due to the evolution or due to the mutation. And uh, and uh, there are for examples, if we say, we can say it has an actin gene, alpha and beta globin gene, immunoglobulin gene, etc. And then there are three types of pseudogenes we said, that is processed pseudogene, unprocessed pseudogenes, unitary pseudogenes. Then we said there are two general classes, orphans and retro pseudogenes. If we compare the orphans and retro pseudogenes, it will be easy for us to learn. And then we said its role, and we said that it's not exactly understood, but there are few rules, and it's mainly important in the evolution of higher organisms. So yeah, that's all about the pseudogenes. I hope you all have understood. Thank you.